In this video, I'm going to talk about the basic concepts of a blockchain. So why is it called a blockchain? This is a very simplified example. Let's say we have a block X. This block X just got mined and it contains all the transactions that happened during that time. The new block that gets mined is the block X plus 1. Again, it contains all the transactions, but it also contains a part of the previous block. So it's chained together. Again, a new block X plus 2 is mined. It contains all the transactions and it contains again a part of the previous block X plus 1. So it's again chained together. But what about the first block? The first block is called the Genesis block. It can be configured in Go Ethereum, and we will talk about this later. It's called the Genesis JSON file, which is a configuration file. In the mainnet, everybody connects to an existing blockchain, but someone had to start with the Genesis block. If you are creating your own private network, and we will do this quite a lot later, then it's technically exactly the same as all the other networks, just that you are in control and you define how the network looks like with this Genesis block and the Genesis JSON configuration file. Plus, on a private network, you are probably the only node that is running there, but more can connect to it. So let's go back to our example. We have our first block, which is the block 0. It's called the Genesis block. Then we have a block 1. It contains all the transactions and it contains a part of the previous block, the block 0. And then we have a block 2, and it again contains all the transactions and a part of the previous block, the block 1. So how is a new block created anyway? A new block is created by miners. It needs to be mined. The miners need to solve something like a mathematical riddle. It's a very hard to find answer, but it's very easy to verify if it's correct. Let's think of a simplified example. Something like 3 times x is 9, and we have to find the x. Of course, it's easy in this example because x is 3, but it's also easy to verify. We just have to plug in our answer and see if the results fits. Our Bitcoin and Ethereum main networks are running currently on a proof of work that needs a lot of calculating power and electricity to solve the riddle and mine a new block. But how is a transaction created? If you want to send value, data, or an amount of ether to the network, or you want to create a smart contract, you need to sign it with your private key. These two together result in a valid transaction and they are sent into the network. And when the next block is mined, then the transaction will be included in the block. What are private keys and public keys and addresses? A private key is a cryptographic hash that is created on your computer. You can additionally set a password for the private key, but the important part is it's used to sign the transactions. The private key has to be kept in private. Don't lose it, or else you will have no more access to your ether or to your smart contracts which are on the blockchain. The public key is derived from the private key. It's used to verify transactions. The public key cannot bring back your private key. An Ethereum address is derived from the public key. Let's have a look where the location of the blockchain is. This question came up quite a bit. The blockchain is saved on every computer. It's a massive distributed database. The good thing, it's trusted if you and only you have the private key to your accounts. The blockchain is accessible through clients, and there are different implementations of so-called Ethereum clients. There is one implementation in Go. It's called the Go Ethereum or Geth client. There is a parity client, Ethereum++, and there are other clients like a MetaMask. If you start Go Ethereum or Geth the first time on your computer, it starts to download the whole blockchain. That means that really the whole blockchain is saved on every computer that is running a Go Ethereum node, which also means if you are creating distributed apps or dApps, you can assume that this dApp has access to the blockchain through the client computer. Unlike traditional database systems, the blockchain is not stored on the server side. You can assume that the blockchain is accessible through the local host. Let's have a quick look what is proof of stake. Proof of work, which we discussed previously, needs to put a lot of electricity and a lot of power in order to mine new blocks. That means it's not very good for the environment and it burns a lot of energy. With proof of stake, you need to put in Ether or a stake to mine new blocks. It's currently in the testing phase. It's possible to switch in around 2018 with the Casper network. And the Casper network will probably be a mix between proof of work and proof of stake. But there is a lot of work to be done still, and we will see what's coming up. Here's what you learned. All the chains, private, public, test chains, and so on, they are technically all the same. They all start with a Genesis block. Also, don't lose your private keys. Put them in a safe place and eventually even put a strong password on top of them. Access to the blockchain is on the client side. That means when you write the dApps, you can assume that the blockchain is accessible through localhost. And the current way of mining is proof of work. Any questions or suggestions? Head over to the Q&A. We are answering there regularly. If you want to leave us some feedback, that would be great. We are very happy about feedback. Disappointed or found a problem? Not a problem at all. Send us a message. Or head over to the course repository, which we are updating regularly.